Pythagoras theorem. It says c square is equal to a square plus b square, which means if we have a right angle triangle where c is the hypotenuse and a and b are the legs, then it works perfectly. But do we know how did Pythagoras work it out? Do we know what is the proof of the Pythagoras theorem? Well, this video is right about the proof, and jump straight into the video to find out how it looks. Hello people, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success to yet another video of ours. Exponent to Success is an initiative that helps to add an exponent to your learning curve. In case you are new here or if this is the first time that you are visiting this channel, I suggest you should subscribe to the channel right now so that you do not miss out on any future content from us. In the last video, we talked about the concept of similarity of triangles. If you missed that video or you were not able to see it, just click on the top right corner of the screen and the link will take you straight to the video. This video is about learning to prove Pythagoras theorem. Pythagoras theorem says that in case we have a right angle triangle like this, and if we have the sides as A, B, and C, C is taken as always the longest side, which is called the hypotenuse. Hypotenuse is recognized as the side being opposite to the right angle. So Pythagoras theorem says that C square is equal to A square plus B square. Now, how does it work? How did Pythagoras prove this? That's what we need to learn in this video, and this video is exactly about that. Though there are about 300 different ways in which Pythagoras theorem could be proved, but we are going to talk about only 3 such ways, out of which one way will be based on the similarity of triangles, which we spoke about in the last video. Well, to prove the Pythagoras theorem, the first thing that we have to do is let us start with a square. And let me make some divisions also on the square. So what I'm going to do is I'm going to divide the square into certain parts. So let me say that I divide it here. So let this part be A and this part be B. Similarly, I'll divide the other sides also in the same ratio. So let this part be B and let this part be A. Let this part be B and this part is obviously A then. Again, this part is B and this is A. Next, what I'm going to do is I'm going to connect these adjacent places. So I'm going to draw a line from here to here, from here to here, from here to here, and last line from here to here. Now what we have inside is another square. Uh, let us say that the side of the square is C. So let us call this C. Let us first find out the area of the complete square, the area of the larger square. So we know that the side length of each square is A plus B. So obviously area of the square, this has to be A plus B whole squared. And if we simplify that further, it becomes according to the identity A square plus B square plus 2AB. Now area of square can also be calculated as in a different way, where we see that there are 5 different figures inside it. There's one triangle, the second triangle, the third triangle, the fourth triangle, and the fifth is a square. So obviously the area is the sum of the areas of all these figures. The area of the square, we know that it has a side length of C. So the area of the square will obviously be C square. Plus it has to be the area of the 4 triangles. So let us look at this triangle first, the one that we have here, this one. So the area of a triangle is half base into height, and you know that so in case I take it as half, base is B and height is A. So obviously it has to be half AB, and this is not one triangle, but there are 4 different triangles here of the same length and breadth. So A times B, this also has to be half A times B, this also has to be half times AB, and this also has to be half times AB. Now obviously if we so there are 4 triangles here, so we can just say it is 4 times half AB, and we know that the 2 and 4 can get cancelled, and we get what we get is C square plus 2AB. So that is the area of the complete figure if we add the areas of all the 5 figures enclosed. And since both of these are the area of the same square, which is the largest square, we can say that C square plus 2AB is equal to A square plus B square plus 2AB. and 2ab we can cancel out on both sides, and what we are left with is c square is equal to a square plus b square. And that's the Pythagoras theorem proved for you. Well, we can prove Pythagoras theorem in another way also. Uh, now, let me take another square here. Let's say that the length of each side of this square is c units. So obviously area of the larger square is equal to c square. And let me now divide it into parts. Let me draw a line from here to here. And let me draw a line from here to here. Such that we get this part as A, this part as B. Again, this is A, this is B, this is A, this is B, this is A, and this is B. The area of this square, the bigger square that we have, is A square. The area of the smaller square here that we have is B square. And for the time being, let me remove out these extra portions that we have. Let me remove these extra parts out, the rectangles. The area of each rectangle here is AB. So for the time being, let me remove that. And let's come back to the old figure now. In the old figure also, if we remove these triangles that we have, what we are left with is the inner square, the C square. And coming back to this figure, if we have removed these triangles, why I'm saying that they are triangles is because if I draw a diagonal from here to here and another diagonal from here to here, what we get is two triangles. The area of each triangle is half times the A times B, the base times the height, which is half AB. So there are four triangles. So 4 into 2 is equal to 2AB. So if we remove this area of 2AB, what we are left with is A square plus B square. And from the previous figure also, if we remove these four triangles, the area of which worked out to be 2AB, we can get it as what we are left with is C square. So you see how if we remove the same four triangles from both the figures, what we are left with is c square is equal to a square plus b square. So that's the Pythagoras theorem proved for you once again. Okay, we are back with another triangle. This time it's a right angle triangle that we have taken, and let's call this triangle as ABC. Say that angle A in this case is 90 degrees. And if we draw a perpendicular from angle A to the side BC, let us say it meets at the point D, and here this again is 90 degrees. So we know that in triangle ABC, angle A is equal to 90 degrees. In triangle ADB, angle D is equal to 90 degrees. We know that in both the triangles ABC and ADB, this triangle that I'm talking about, angle B happens to be the same. So whatever that angle B is, angle B is equal to the angle B here. And since both the angles are equal, we can obviously say that this angle here, which is angle DAB, is the same as angle ACB. Because if two angles of a triangle are equal, then the third obviously has to be equal. So we can say angle DAB is equal to angle ACB. Now, since we have this, we can say that both these triangles are equiangular. And what we mean by equiangular is that the angles of both the triangles, or all angles of both the triangles, are equal. Thus, we can say that both these triangles are similar to each other. So we can say triangle ABC is similar to, now this is the sign that we use for similar. Like in congruent, we say we use an equal to sign and then this. So here it is just this without the equal to sign. So this means that the triangles are similar, and it is read as triangle ABC is similar to triangle. Now, just like in congruence of triangles, we have to write the name of the triangle in such a way that each corresponding alphabet of the first triangle corresponds with the alphabet of the second triangle. So in the triangle ABC, we know that angle A is a right angle or the 90 degrees angle. So obviously in the second triangle also we'll have to start with the right angle or the 90-degree triangle, which in this case happens to be angle D. And then from A we move on to B, and B is the common angle in both the triangles. So obviously B will come here, and then we go to C, and the other side in this is A. And since both the triangles are similar, then we can talk about the similarity or the proportion of sides also, that we can say that AB is or the proportion between AB and DB should be the same as BC and AB, which should again be the same as AC and AD. We can also say, if we look at the other triangle also, we have again this as a 90-degree angle. Angle C is common in both the triangles. So we can also say that triangle ABC is also similar to triangle DAC. Now that's the similarity of sides, corresponding sides, sorry. So the proportion of sides becomes AB over AD is the same as BC over AC, which will be the same as AC over AD. So sorry, CD. Now what do we have here? If we take this part here, we can say that AB, and if we cross multiply both of them, we can say that AB square is the same as BC times BD or DB, whatever you can say, whatever you may call it. And if we take this equation here, we see that AC square is the same as BC times CD. And if we add both these sides, we get both these equations. Let's call this equation number 1, and let us call this as equation number 2. If we add these two equations, we get AB square plus AC square. So that you see is the left hand side of both the equations, is the same as BC times BD plus BC times CD. And if we can factor out BC from this, we get BC times BD plus CD, which should be equal to AB square plus AC square. Or we can say that AB square plus AC square should be the same as BC times BD plus CD. Now let's look at the figure. BD is this part over here and CD is this part over here. So obviously BD plus CD can also be written as BC, which makes it BC times BC. So BC square is equal to AB square plus AC square. And you see how BC in this case in the bigger triangle, it's the side opposite to the right angle. So BC is the hypotenuse, which we call as C square. AB is one of the sides, one of the legs of the triangle, which we can call as A square, and AC is the other leg of the triangle, which we can call as B square. So that's the Pythagoras theorem again for you. So you see how we could prove the Pythagoras theorem three different ways. And of course, like I said, there are 300 different ways in which the Pythagoras theorem can be proved, but these are just three of the ways. And since we learned similar triangles in the last video, I thought it would be best if we could prove the Pythagoras theorem once again here. In the comment section, I would like to hear whether you have faced any problems with Pythagoras theorem before, whether you have really understood how the Pythagoras theorem works, or how do we prove it, why does it work. Well, if you didn't know, then this is the video for you, and I would like to hear about it. How did you find the video? How did you like it? I would like to know everything about your comments here. Do give me a thumbs up if you like the video. Do share it with your friends, and in case you haven't subscribed to the channel as yet, this is the right time that you must do it. Just click on the subscribe button here. Do share the video with your friends. You can watch these videos on the left side as your next videos, and take care and God bless.